Good morning, students. So first problem, this is example number 1. So this is what is called as a block diagram representation of a discrete signal system. You are supposed to write for this block diagram difference equation. So in the difference equation must contain only output and its shifts on one side and input and its shifts on the other side. So today I will work out two examples. So this is first example. So this is one part, this is another part. So this part is what is called as feedback. See one thing now, the signal here is tapped and here I will show a summary here. I will show you a summary here. So this is what is called as feedback connection. So signal is tapped here and it is get multiplied with minus 1 by 4 and fed to this summer. And the summer receives this signal as well as this signal. The addition of these two signals here is shifted by 1 unit and it comes here. And that is fed to another part of the system. Another summer is here and this is output, final output. So final output is multiplied with 1 by 4 fed to summer and it is also receiving, summer also receiving signal here. The summation here which comes here is shifted by 1 unit and this is also what is known as feedback connection. So for this block diagram you have to write what is known as difference equation. First what I suggest you is, first you write here signals are named here. So xn, yn. In between xn and yn there is no naming of other signals. So what I will do here, I will call this signal as zn. I will call this signal as zn. So zn is tapped here and it is multiplied with minus 1 by 4. That is minus 1 by 4 z of n comes here and here the signal here is summation of these two, that is x of n minus 1 by 4 z of n, and next this is a block, a shift block of 1 unit, Now what is signal here? The signal here is shift on this signal, shift of 1 unit. Wherever there is n, replace it by n minus 1. Therefore, the signal here is x of n minus 1 minus 1 by 4 z of n minus 1. Next, this is yn. So what is signal here? 1 by 4 yn. So 1 by 4 yn, and what is signal here? The signal here is zn plus 1 by 4 y of n. Next, the signal here ultimately here is a shift of 1 unit on this signal, that is y of n is equal to z of n minus 1 plus 1 by 4 y of n. So first what I will suggest you is, you first write equations. You just write equations and then we shall do manipulations. So first I will write here, what is y of n here? Y of n is equal to z n minus 1 plus 1 by 4 y of n. 1 by 4 y of n. This is y of n. Y of n is zn minus 1 1 by 4 yn. This is equation number 1. Equation number 2. What is z of n? Z of n is equal to x of n minus 1 minus 1 by 4 z of n minus 1. This is equation number 2. We have to manipulate these two equations. You have to manipulate these two equations, and the z to the power z of n or z of n minus 1 should not appear in the difference equation, and we shall see how to manipulate these two equations. So first equation is equation for yn, and this is equation for zn. We have to manipulate these two equations to write difference equations. A slight correction here, I had left out 1 here, so I have added here. Now we have to manipulate these two equations. I will show how to manipulate these two equations. From this equation you write z of n minus 1, because ultimately when you write the difference equation, z should not be in picture. Therefore you write what is z of n minus 1. Z of n minus 1 equals, taking it to this side, y of n minus 1 by 4 y of n minus 1. Now substitute this z n minus 1 here. If you substitute here, z of n is equal to x of n minus 1 minus 1 by 4 z of n minus 1. Z of n minus 1 is y of n minus 1 by 4 y of n minus 1. Simplifying this, z of n is equal to x of n minus 1 minus 1 by 4 y of n plus 1 by 16 y of n minus 1. Now this is z of n. Now I want to write what is, if I write this is z of n, this is z of n. What is z of n minus 1? Z of n minus 1, that means a shift of 1 unit on both the sides. We get z of n minus 1. Wherever there is n, replace it by n minus 1. So this becomes x of n minus 1 minus 1 minus 1 by 4 y of n minus 1 plus 1 by 16 y of n minus 1 minus 1. Therefore this is z of n minus 1. Therefore z of n minus 1 is equal to x of n minus 2 minus 1 by 4 y of n minus 1 plus 1 by 16 y of n minus 2. Now you replace here. Take once again equation number 1. Take equation number 1 and substitute z of n minus 1. If you substitute here, it becomes y of n is equal to x of n minus 2 minus 1 by 4 y of n minus 1 y of n minus 1 plus 1 by 16 plus 1 by 16 y of n minus 2 y of n minus 2 plus 1 by 4 y of 1 by 4 y of n minus 1 n minus 1. Now shuffle the terms. So if you shuffle the terms, so here on one side what you will get, y of 1 by 16 minus 1 by 16 y of n minus 2 minus, so here this minus 1 by 4 plus 1 by 4 y of n minus 1 cancels. Therefore, we are left with 1 by 16 y of n minus 2 plus y of n is equal to x of n minus 2. X of n minus 2. This is what is called as difference equation. This is what is called as difference equation. And the maximum shift is 2. Therefore, this difference equation is of order 2. So, first you have to write correctly equations and then merely manipulation. That's all. Thank you.